Okay, this is Honors Pre-Calc homework from section 28-2, page 391, 392, 11 through 20. Okay, so number 11 looks like this. I'm looking at this book right here. It looks like this in the book. Okay, so the first problem is 7:162, and it says determine the rectangular coordinates for each polar. I'm reading right here. Determine the rectangular coordinates for each polar point. So this is a polar point, and we're going to do rectangular coordinates. So it is 7 cosine of 162 and 7 sine of 162. And we'll use our calculator. So let's make sure we're in degrees. We are. Clear this out. So we have 7 cosine of 162. And we have 7 sine of 162. So our answers are negative 6.657. Scared me. What are you doing?
We got track practice.
I did videos for 5 days for you guys.
I'm not. They popped up on my phone.
Okay, so this is our first answer. Okay, someone just scared me. This is, by the way, this is Monday, April 2nd. Homework. You guys can turn this homework in to the sub and have them put it in the Manila folder that says Monday, April 2nd. When you're done, you can give it to me Monday at the end of the class, or you can give it to me Tuesday morning. Just make sure it gets in the correct folder. So when I'm grading these homeworks, when I come back, that they're all in the correct folder, okay? Number 12, negative 4, negative 30 degrees. So we have negative 4 cosine of negative 30 and negative 4 sine of negative 30. So punch that in. Negative 4 cosine of 30. I think that was negative 30, wasn't it? Negative 30 makes a difference. And that's this. So it's negative 3.464. And then we have negative 4. You know what? If you just want to do this and just go back and do sine, I don't know if it's quicker. There's sine of the same thing. It's 2. That's your answer to 12. Pretty easy, huh? 13. We have 5 and 270. I'm going to try to do this one without our calculator. 5 cosine of 270 and 5 sine of 270. Well, the coordinates of 270 are 0, negative 1, remember? So the cosine of 270 is 0, so this is 5 times 0, which is 0. And the sine of 270 is negative 1, so 5 times negative 1 is negative 5. Try it on a calculator and see if we're right. So 14, we have negative 6 and 45. So we have negative 6 cosine of 45, negative 6 sine of 45. So it's negative 6 radical 2 over 2, and it's negative 6 radical 2 over 2, because it's the same thing. So this would be negative 3 radical 2 and negative 3 radical 2 if I wanted exact answers. But if I did not want exact answers, it would be negative 6 cosine of 45, which is negative 4.243, and I think that's the same thing as the other one, right? So I take either answer right now. The book shows both answers, and I'm showing both answers. So 24 and 16. Since 16 is not a unit circle number, you would need your calculator for this one. 24 cosine of 16 is 23.07, and 24 sine of 16, which is 6.615. Both positive. And 16. 9.2 is cosine of negative 104. Oops, that's not a print. That should be a comma. Sorry about that. And 9.2 sine of negative 104. So we have 9.2. What did I say? Cosine of negative 104 for this one is a negative 2.226. You can't see anything. Oh my gosh, I'm so sorry. You haven't seen anything I've done. 9.2, I'm not even paying attention. Sine of negative 104 is negative 8.9267. So if you couldn't see what I did before, there's 16. There's 14. Here's 12. I don't know if you saw any of these, but I'm not redoing it. Here's 15. 13. And 11. So now we're on 17. So make sure, this is really hard to see here. I gotta do this over. Let's see here. 17. 17 says, a rider on a horseback leaves the stable and heads 60 degrees north of west for 6 miles. So if you're seeing what that, wondering what that looks like, 3, 4, 5, 6. 60 degrees north of west is about right here. The 6 ring, 2, 3, 4, 5, 6. It looks like about that. If you're writing this, it says A, determine the polar coordinates of the rider on a polar grid in units of mile where the pole 0 represents the stable on the polar axis points due east. So that would be 6, and then you would not use 60. You would use 90 plus 30. It's 120, or you do 180 minus 60. Either way, it's going to be 120 degrees. 120 degrees is the same thing as 60 degrees north of west. Okay? So part B says, explain how you can use rectangular coordinates to describe the location of the rider in relation to the stable. So you could do 6 cosine of 120, 6 sine of 120. Cosine of 120 is what, negative 1/2. And sine of 120 is positive radical 3 over 2. So it would be like going negative 3 to the left and 3 radical 3 to the right. If you want the exact decimal approximation, you would go 6 cosine of 120, which is about, well, obviously, I don't know why I punched that in the calculator. 6 sine of 120, that's the one I wanted to punch in the calculator. That's about 5.2. So if you're going by miles, you might go 3 miles to the left and 5.2 miles up. So if you're looking at this, so like 1, 2, 3 miles to the left, and then 5.2 miles up. So if you were making a triangle here, this is actually like 3 and 5.2. Okay, that's it. 17. 18. If a point on a polar grid has a theta coordinate of 180 degrees, that goes this way, right? What can you conclude about the location of the point on a rectangular coordinate grid? Explain your reasoning. So basically, the R could be anything. You could say this, negative R0, or you could say R180, first of all. You could use either one of those. I guess you could say any point that lies over here has a y coordinate of 0. No, x coordinate of 0. I'm sorry, y coordinate of 0. You would have to do like r cosine of 180, r sine of 180, and since 180's coordinates are negative 1, 0, it would be r times negative 1, comma r times 0. So you could say negative 1 times whatever the r is, and then r times 0 is 0. So any of your coordinates, whatever your r is, you just say the negative of that. I'm not sure what else they want on that problem. That's all I'm going to tell you. So 19. Point P on a polar grid has coordinates 8 and 150. That's what the book's saying. What is the slope of the ray with its endpoint at the pole 0 that passes through point P. Explain how you determine the answer. Well, in order to figure out a slope, you need 2 points. The pole's first point, you can say it's 0, 0. It's like 0 at 0 degrees. But 0 at 0 degrees is 0, 0 as a coordinate. But what is 8, 150? So 8, 150 would be 8 cosine of 150, 8 sine of 150. So cosine of 150, let's just do this on the calculator. 8 cosine of 150 is negative 6.928, so we'll say 3. And 8 sine of 150 is 4. So if you did a slope of these points right here, you would go 4 minus 0 over negative 6.93. So you'd go 4 divided by negative 6.93. So you can say that the slope is negative 0.577. They have a fraction here, negative 406.93, I guess. Now, if you wanted to do this with exact numbers, since 150 is a unit circle, 8 cosine of 150. Cosine of 150, let's think, it's in the second quadrant, so cosine's negative. It's a 30 degree, so that'd be 8 times negative radical 3 over 2, comma, 8, and then that would be 1/2. Sine is positive. So this would be negative 4 radical 3 and 4. So the slope would be 4 divided by negative 4 radical 3, which is negative 1 over radical 3, or negative radical 3 over 3. If you really wanted to do the extra work, there it is. That could be your slope, or I would accept the negative 0.577. 20. So the diagram shows the location of a smaller plane on a radar screen. So here's the picture. It says at time t 15 minutes. So at t equals 0, the plane was here. 15 minutes later, the plane has moved this direction. The radii of the concentric circles on the polar grid increase in increments of 5 miles, so each ring is 5 miles. And the rays from the center of the grid are 15 degrees apart. Determine the rectangular coordinates of the plane at t equals 0 and at t equals 15. Round coordinates to the nearest point. So this point right here, if you're looking here, the rings 5, 10, 15, 20, 25, 30, 35, 40. So it looks like 45 and 75 degrees. So in 20,